Hey, how are you, everybody? Hopefully, everybody did well on this homework assignment. Didn't have too much trouble. Let's go ahead and go over it. 5.1.4. Big smiley face on that, right? Got to smile about things. Life is good, right? Numbers getting better. Here we go. So that first one, 534, we were going to use a generic rectangle to multiply a mixed number, 4 1/5 times what and 2/3, right? Well, 4 times what is 12? Well, you figure out that's going to be a 3, right? And then 3 times 1/5 is 3/5, right? And 4 times 2/3, remember we set that up for you? Multiplying fractions is easy because you just go straight across the top. 4 times 2, straight across the bottom. 1 times 3. Okay. Now you can go simplify that because it's improper and say how many times does 3 go into 8? That's twice. And remember, your remainder is going to go on top, and what was outside the box, the divisors, what they call that, goes on the bottom. So this becomes 2 2/3. And then 2 times 1, right? Because I'm going 2/3 times 1/5 is 2, and 3 times 5 is 15. So I have 2/15 here. Now I can already tell I want to simplify, or not simplify, I want to change the denominator for these when I go add these, right? So I got a 12. I'm going to go and put the 3/5 next to it. That's allowed. And I'm going to put the 2 2/3 and this 2/15. I'm going to add it. So I combine these two. I don't know if you guys noticed that. Those two products. Now I'm getting a sum. I'm adding products to get a sum. Okay, don't get confused. The products were the answer to the multiplication problems. I'm going to add those and get a sum, which is a total to an addition problem. Now, this is 2/15, and that's what I'm going to, so I don't have to change that one. But this 2/3, how many 15ths is that? Well, I did 3 times 5, so I got to go 2 times 5. 2/3 is the same as 10/15. Okay, and on this one, I did 5 times 3 to get my 15. I'm going to zoom in a little bit, see if that makes it a little bit brighter for you, a little easier to see, a little bit. Okay, so I did 3 times 5, so I go to 3 times 3, right? So I have 9/15 plus 10 more, that's 19, plus 2 more is 21/15, and then 12 and 2 is 14. Now that 21/15, that's more than one whole. One whole is 15/15. So I'm going to carry that over, move this up here and say that's 15, because I carried that over, 1 plus the 14. That was 15/15. And if I do 21 minus 15, that means I would have been left with 6/15. And I'm almost done. Why am I not done? Because I can simplify 6/15, because 3 goes into both the top and the bottom. 3 goes into 6 twice, goes into 15 5 times. So 15 2/15. Okay, that's my answer to this. A lot of work. Now, the other way of doing these, 4 1/5 times 3 2/3, is to use the C method and make these improper fractions, then just multiply, and then you got to simplify for sure. So 5 times 4 is 20, plus 1 is 21/5. It's the same as 4 1/5. 3 times 3 is 9, plus 2 is 11, and that's thirds. Now the bottom of this is easy, 3 times 5. At the top, I got to go 11 times 21. Doing standard algorithm here. Okay, 1 times 21, placeholder 1 times 21. So 231. So 231/15. Simplify. 15 goes into 23 one time, and 15 goes into 75 5 times. 5 times 15. And then I get the 15 6/15 and go simplify. So I did it right. Okay. All right. 5-35, we were supposed to draw a rectangle and then increase the original rectangle by a ratio of 5-2. That means every 2 in my original becomes a 5. Okay, and I think I gave you the hint to say, hey, use even sides. Don't use my same rectangle, but use even sides, and it'll be a little bit easier. Why? Because there's a 2. That's going to become a 5. This 4 has 2 2s, so 5 and 5 makes 10. So my new rectangle is going to be 5 wide and 10 tall. I didn't have much room to spare, did I? Okay, that's my new dimensions. 4 went, compared to 2, went to 10 by 5. That is what they call a proportion. And when you increase the shape of something, things should be in proportion. The height, right? So the 10 is to 4, like the width is to the width, 5 is to 2. Okay, I can also say the width of the small one compared to the height of the small one should equal the width of the big one compared to the height of the big one. And that is true. Okay, this is something we'll be doing later this chapter or next chapter. It's called proportions, and they're special kind of ratios, and they're kind of cool. Okay, it'll allow you, here's something for you. Plant this seed in your brain. It'll allow you to measure the height of the lamppost out in front of your street without climbing it, which is good. You don't want to climb a lamppost, right? But on a sunny day, you get out a ladder, and the ladder doesn't have to be big enough to reach the, yeah, you will learn that later. Fun stuff. On to 5-36. We got to put all these. Now, which one of these are greater than or equal to 1 1/2? Well, let's go ahead and try to put all these down here. Right? I circled these are bigger than 1. Okay. And 4 over 2, that's the same as 2 over 1. So I'm going to put my 4 over 2 there. Okay. 30 sixteenths, that's almost 32 sixteenths. 32 is double 16. So that would be almost 2. And 22 elevenths would be 2 also. 2 sixteenths, if I go bigger, 2 sixteenths compared to 2 elevenths, 2 sixteenths is a smaller amount. So this one ends up being here, 30 sixteenths, 20 elevenths. Now, this one over here is just, it's not just a little bit bigger than 1, like 7/6 and 3 13/12. This would be 14/12, right? So this is bigger than that by a little bit. 15/9. 9/9 is 1 whole. 6/9, that's 1 2/3. That's going to be this one, 15/9. All right. Now I have these next 3, 6/5, 7/6, a fifth. If you're dividing a pizza that's sharing with 5 people, you get a bigger piece than if you share with 6 people. So 6/5 ends up being bigger than 7/6. So we already figured out 7/6 is the same as 14/12. So that's bigger, right? So 13/12 is going to be the smallest one of these that's bigger than 1. And then we're going with 7/6, and then we're going with 6/5. So we got the top half done. Okay. Now, what's the smallest one in this whole bunch? Let's see. 2/20 is 1/10. Sharing with 10, you get more than sharing with 12. So 1/12 is smaller than that. 1/12 would be 2/24. This is 2/17. It's bigger. 1/12 looks like it's going to be the smallest one. 12 times 8 equals 96. 8, 96. I'm going to have to do some math on that one. Okay, I don't know about those two. I do know 98 hundredths is pretty close to 1 whole. That is really close. Okay, and the next one, that 6/7 is pretty close to a whole. And 12/25ths is a little less than a half, and 6/11ths is a little more than a half. 6/11ths and 12/25ths. Okay, so let's cross those out. So the key here is 1/12 and 6/100ths and 2/17. 2/17 is 1/8.5. That's a bigger piece than 1/12. 1/12 is smaller. This is 3/50, which is 1/16.5. That's a smaller piece than that, right? So 1/16.5. So 6/100ths is going to be the smallest here. And then 1/12. And then, I got another one in there. 2/17, 2/12. This is 1/10. And 1/8.5. Okay, so 2/20ths. Yeah, you get two pieces sharing with 20 versus two pieces sharing with 17. You get more with the 17. All right, I got them all in order. Whew, that was a lot of work. All right, which are greater than or equal to 1 1/2? 1 1/2. That's what. So these here. So I'm going to say 15/9, 20/11, 30/16, and 4/2. Boom, that's my answer. Which are close to 1? Well, I'm going to go ahead and include 6/7. That's pretty close. All right, 7/7 is 1. 98/100. 13/12, right? 12/12 is one whole. 7/6, 6/6 is one whole. And 6/5 are pretty close, right? Okay. All right. Which are close to a half? 12/25ths, right? Half of 25 is 12.5. And 6/11ths, half of 11 is 5.5. Those are both pretty close. Which are close to 0? We're going to use these bottom four. 6/100ths, 1/12, 2/20ths, which is 1/10, right? And 2/17ths, which is 8.5. That sounds weird, huh? You'll learn how to do that later. All right, let's get my answers here. Okay, you pause it right here and check all your answers. Copy them down. Okay. All right, here we go. Now, 8%. Could that be 8/10? Now, I'm allowed to add zeros. So 8/10 is the same as 80/100. Is the same as 800. So all three of these are the same. So they can't be equal to all of these. Remember our rule. Okay, to change a decimal to percent, you move it over 2 spots. 8/10 is 80%. Okay, so 0.8 and 0.8. So this one works. 8% is not equal to 0.8. 8%, if I go from percent to decimal, I move it 2 spots this way. So 8%, it was here, move it back 2 spots, is 0.08. Okay, 800%, moving it back 2 spots, boom, boom, it is 8. That's not equal. We're going to say 800% equals 8. Okay, good enough. 5-3/8. We're dividing. Okay, when I divide 10 into 75, it goes 7 times. I get a remainder, so I'm going to add a decimal, bring it up, add a 0, bring it down. 10 goes into 50. So 75 divided by 10 is 7.5, right? 75 divided by 100. 100 goes into 700 7 times. I get a remainder, so I'm going to add another 0, bring it down. 100 goes into 500. So 75 divided by 100 equals 0.75. Now 75 divided by 1,000, 1,000 won't even go into 750, but it's after the decimal. So I got to put a 0 there, or say 0 times this, right? Subtract, bring down the next 0. Now 1,000 goes into 7,000 7 times, right? I'm going to add another 0, bring it down, and 1,000 goes into 5,000. Okay, Now, do you see a pattern here? Okay. If you've been watching my warm-ups, you kind of already know the answer to this, right? But 75 divided by 10 is 7.5. 75 divided by 100 is 0.75. 75 divided by 1,000 is 0.075. What's happening here? Hopefully you saw that the decimal seems to be moving that way to the left each time I divide by a power of 10 for each zero. So 75, move the decimal one spot because there's 1 0 and 10, it ends up 7.5. 75 divided by 100, move it 2 spots, there's 2 zeros there. And I go boom, boom, it goes 0.75, and 1,000, 1, 2, 3, boom, 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 0.07. Okay, so dividing, right? Remember we said your fifth grade teacher used to say, add a zero when you multiply by 10, add 2 zeros when you multiply. And I'm saying, hey, shift that a little bit and change it to move the decimal to the right when you multiply by 10, one spot, to the right when you multiply by 100, 2 spots, to the right when you multiply by 1,000, 3 spots. And now you can do decimals, but also now when you divide, you're just moving it to the left, however many zeros are. Okay? Write that explanation. I don't want this video too long. Put it in words like you're trying to explain it to your third grade brother, or imaginary third grade brother for some of you, most of you. Okay? All right. Hopefully you got that. Hopefully you have a great day.